Hi students, today we shall discuss a new point in operating system, that is file concept. We shall first see what is the concept of a file. A file is a named collection of related information that is recorded on secondary storage. So file is nothing but a collection of related information that is saved on the hard disk. A file is a sequence of bits, bytes, lines or records whose meaning is defined by the file's user and creator. That is, a user will create a file. That is why we call him a file's creator. All the related information will be kept in one single file. So we can say that the file is a sequence of bits, bytes, lines or records. The operating system makes data storage and retrieval easier by providing an abstract view of storage devices by hiding their internal structure so that the users can directly access the data without exactly knowing where and how the data is actually stored. So when we create a file, for example, we are creating a file in Microsoft Word, we just type the file and save it. The remaining part at the hardware level is taken care of by the operating system. So the internal structure and the low level functioning is seen by the operating system. The operating system defines a logical storage unit known as a file, and all the data is stored in the form of a file. It can store different types of data like text, graphics, database, executable code, sound and videos, and on the basis of the data, a file can be categorized as data file, graphic file, database file, executable file, sound file, video file, etc. So now we have understood what is a file concept. Next we will move on to file types. We can store different types of files in a computer. As we have previously seen that there are different types of files that can be stored on a computer. The most common technique to implement a file type is by providing extension to a file. You know that whenever we are saving a file, the file should have an extension. The file name is divided into two parts, with the two parts separated by a period, that is a dot symbol, where the first part is the name and the second part after the period is the file extension. So for example, file1.txt. So file1 is the name of the file and dot is the period given and txt is the file extension. A file extension is generally 1 to 3 characters long. It indicates the type of file and operations. The operations will be read, write and execute that can be performed on the file. A file with .exe or .com extension is usually an executable file. File extension helps the operating system to know about the application program that has created the file. So for example, the file with .txt extension will be opened with the text editor. So with the file extension, the operating system understands what type of a file it is. So here in this example, .txt tells the operating system that this is a notepad file. So this file having extension .txt will be opened in notepad, not in Microsoft Word. Similarly, if we save a file having extension .exe, that .exe will not get opened in any application because it is an executable file. So with this we have understood the different types of files. Next we shall see file operations. File operations are the functions that can be performed on a file. That is, what different operations can be performed on a particular file. The operating system handles the file operation through the use of system calls. Previous lectures we have seen what are system calls. So the operating system uses the system calls to perform operations on the files. The various operations that can be performed on a file are create, write, read, seek, delete, open, append, rename and close a file. Now we shall see each of this file operation in detail. So the first operation which we are going to see is create a file. To bring a file into existence, create system call is used. So whenever the user creates a new file, wants a new file to be created, they will just create it in any application. But the operating system will use the create system call to create the new file. When this system call is used, the operating system searches for free space in the file system and allocates it to the file. So when we create a file in any application, we just give the name extension and save it. But the operating system has much to do. The operating system has to find a free space in the hard disk and in the file system. If the space is available, then it will be allocated to that particular file. In addition, the operating system makes a directory entry to record the name, location and other pieces of information about the file. Suppose you are creating a file inside a directory or inside a folder, then an entry has to be made giving all the related information about your file in that particular directory. So when you are creating a file, there are these two things done by the operating system. So this is all about the first operation of file, that is create a file. Next we shall see is open a file. To open a file, the open system call is used, which accepts the file name and the access mode as parameters and returns a pointer to the entry in the open file table. So if you want to open a file, the user just double clicks on the file name, but the operating system first has to see what type of file it is depending upon the file extension. When it understands the file extension, it will open that file in that particular application. So when we are opening a file, this operating system uses the open system call. This open system call requires two parameters. First is the file name, that is which file is to be opened. And second parameter is the access mode, that is whether you are opening the file for reading purpose, or you are opening the file for writing purpose, or you are opening the file for appending purpose. So if you are opening the file for the reading purpose, the pointer has to be set from where you are going to read the file. So this is all about the operation of opening a file. Next operation which we are going to see is write to a file. So write to a file means storing or entering some data into a file. To store data into a file, the write system call is used, which accepts the file name and the data to be returned to the file as parameters. So when we are entering a data into a file, the operating system will use the write system call. As discussed previously, the write system call will also require two parameters. First is the name of the file and second is what data is to be returned to the file. So the operating system searches the directory entry to locate the file and writes the data to the specified position in the file and also updates the write pointer to the location where the next write operation is to take place. So when we want to write data to a file, first we have to open it. So the operating system searches for that file. Where the file is available, it will check the directory entry. Through the directory entry, it will get the location of the file. Then it will open the file and write your data into that particular file. So this is all about the system call, the file operation of writing to a file. Next we shall see file operation, that is read a file. To retrieve data from a file, the read system call is used, which accepts the file name, amount of data to be read and read pointer to point to the position from where the data is to be read as parameters. So when we want to read data from a file, the operating system is going to use the read system call. For this read system call, we have to pass again two parameters. One is the file name, that is which file is to be opened for reading purpose, and second is what data you want to read from that particular file. The operating system searches the specified file using the directory entry, performs the read operation and updates the pointer to the new location. So when we want to read a file, first we have to open that file. For opening that file, the operating system searches for that particular file in the directory. In the directory entry, it will get its location, open that file and then perform the read operation. Since the process may be only reading or writing a file at a time, a single pointer called current position pointer can be used for both reading and writing. So the operating system uses only one single pointer, which is known as the current position pointer, and this single pointer does both the job. It does the reading also and writing also. Every time a read or write operation is performed, this pointer must be updated. So for reading a file or writing to a file, we are going to use the current position pointer. So this is all about the file operation, read a file. Next operation which we are going to see is seek file. To position the pointer to a specific position in a file, the seek system call is used. So to move the current position pointer to a particular location, we are going to use the seek system call. Once the pointer is positioned, data can be read from and returned to that position. Next file operation, close a file. When all the operations on a file is completed, it must be closed using the close system call. So when we have finished with reading and writing from a file, we have to close that particular file. For that, the operating system is going to use the system call close. The operating system searches and erases the file entry from the open file table to make space for the new file entries. Next we are going to see delete a file. When a file is not required, the delete system call is used. So we want to delete a file, the operating system will use the delete system call. The operating system searches the file name in the directory listing. Having found the associated entry, it releases all space allocated to the file by erasing its corresponding directory entry. So when we want to delete a particular file, first the operating system will search for that particular file in the directory. When it finds the entry of that file in the directory, it will go to its location and release the space allocated, and that is how the file will get deleted. Next we'll go to the file operation, append a file. To add data at the end of an existing file, append system call is used. This system call works similarly to the write system call, except that it positions the pointer to the end of the file and then perform the write operation. So this is one difference between the write operation and append a file operation. When we open a file for writing into that file, the current position pointer will move to the first location and start writing from the first location. In that case, the previous data will get erased. But if you want to add data to an existing file, keeping the previous data as it is, then we have to perform the append operation on the file. In this case, the current position pointer will move to the last data that was added and then start writing the new data from there onwards. So when we are appending the file, the previous data will be maintained and the new data will be added at the end of the file. So this is appending a file. Next we'll see the last operation, that is rename a file. To change the name of an existing file, rename system call is used. This system call changes the existing entry for the file name in the directory to a new file name. So rename operation, file operation is just to change the file name. So since we are changing the name of the file, we have to also change its directory entry. So this is all about all the file operations. Next we are going to see access methods. Access methods is nothing but how we are going to access the file. The file stored on the disk is required to be retrieved by the user. When it is used, this information must be accessed and read into computer memory. Whenever we want to access a particular file, that file has to be brought from the hard disk, that is secondary storage device, to the primary memory, that is RAM. So that is known as the access method. This information must be accessed and read into computer memory. There are several ways that the information in the file can be accessed. The information stored in the file can be accessed in one of the three ways. That is, first method is sequential access, second method is direct access, and third is a variant of sequential access, that is index sequential method. We shall see each of this access method in detail. First is the sequential access. When the information in the file is accessed in the order of one record after the other, it is called sequential access. It is the easiest file access method. In the case of read operation, the record at the location pointed by the file pointer is read and the file pointer is then advanced to the next record. Similarly, in the case of write operation, the record is returned to the end of the file in the pointer is advanced to the end of the new record. So we shall see how it works. So in the sequential access, the current position of the pointer, if we want to read information or write information, it will go from one record to another record and so on in the forward direction. If you want to read the previous data, then we have to rewind it. So in case of sequential access, it cannot jump from the current position directly to the end position. It has to go through each and every record. Next access method is direct access. Sequential access of this data would be very lengthy and a slow process. To overcome this problem, a data on the disk is stored as block of data with index numbers. So every block will be given a number, index number, which helps to read and write data on the disk in any order. Direct access method is also called the relative access method. Under direct access, file is viewed as a sequence of blocks which are numbered. The records of a file can be read or written in any order using this number. For example, it is possible to read block number 20 and then write block number 4 and then read block number 13. So in case of direct method, we can jump from one block to another block. But in case of sequential access, we have to go in a sequence, that is one record, next record, next record and so on. We cannot directly jump from the first record to the 10th record. So as you can see in this diagram, in sequential access, we have to first read the first record, then second, third, fourth and so on. In case of random access, we can jump from one block to another block, come back to any block and so on. So most applications with large databases require direct access method for immediate access to large amount of information. So if we have very large databases and we want to access records from it, suppose we want to access 150th record. If we use the sequential access method, we have to go from first record, second record, third record and then in this way we will reach to 150th record, which is very time consuming. Instead of that, we can use the direct access method in which the pointer can directly jump to the 150th record. So direct access method can be used or random access method can be used in large databases. We shall see the third access method, that is index sequential method. This method constructs an index for the file. To find a record in the file, we first search the index and then by the help of a pointer, we access the file directly. In the index access method, we can search fast in the large database and also easy. But in this, the method needs some additional space to store the value of the index in the memory. So you can see in the diagram, we have created an index over here. It is same like the index we have in our textbook, in which there is a serial number, the name of the chapter and the page number where the chapter begins. So same way, the operating system maintains an index where which block begins at which memory address. So here you can see R2 begins at AAA-OED. From there it will go over here and then access the data. But the drawback of this access method is we have to separately keep a memory space for this indexing. But the advantage is when we have large databases, we can directly jump to that particular blocks and read the data. So with this we finish with access methods and the file concept. Thank you.